Hi, Noah Anderson. And what I ended up doing mine over was trying to point out that maybe nuclear energy could still be considered a green energy. And what I got mostly, I'm just going to go over everything briefly and not read you a whole big paper, is that nuclear energy is still considered a green energy due to the big factor that a lot of green energies are defined by their reduced carbon footprint. Nuclear energy has a highly reduced carbon footprint because it does not really produce carbon emissions. It Nuclear energy is produced by nuclear fission, which essentially just heats up the nuclear cell, which causes and nuclear energies for fission are used with water to cool them, so the water evaporates, causing steam, causing turbines in the nuclear engine to move, which creates the energy. So with no emissions, it's already a better option than if we were completely fossil fuel or if we were completely coal, which produce extreme amounts of carbon footprints. It's almost like doubling every car on the road currently in the world. So for nuclear power, some of the questions that I was asked are nuclear workers safe? Is it considered green? Is it Where can they be placed? So on and so forth. But for the most part, nuclear workers are safe. They are exposed to minor radiation, but nothing that can be harmful. One of the other questions was where can they be placed? And surprisingly enough, nuclear power plants are actually very small per se, where other green options may take up 360 square miles. A nuclear power plant only has to cover 1 square mile, so it can be placed anywhere, and they are usually placed out of sight and out of mind, so that they are not near anybody or any households or farmland. They are usually just away, which should ease most people because they fear nuclear energy as explosions. They think of Hiroshima and Nagasaki, Chernobyl, 3 Mile Island, of those things. Now, another one of the things is what was the lifespan of uranium to see if it was even renewable per se. And nuclear energy is not necessarily renewable in the same sense that solar, geothermal, wind, or hydropower are. But we currently have about 80 to 100 more years worth of uranium. It really just depends on how much we start to use and in mass. If we use it in mass, it goes down. But a uranium cell only needs to be replaced every 6 years at most. They can be replaced sooner, but to get the most energy out of a nuclear cell, you need to replace it every 6 years before it starts to deplete. Another method for nuclear energy that would produce more power per nuclear cell is a liquid metal reactor, which uses sodium and sodium alloys, which have fairly low melting points that they circulate and they cause the energy in the nuclear reactor from where it's heated, and they can produce. And they are smaller reactors, and they can produce as much energy as a large reactor. This actually came, the Soviets actually attempted this in the 50s, and they produced enough electricity to power what would have been the equivalent of 900,000 United States homes. So if we use those, then it is very easy to get a lot of power out of a reactor, and we can have fewer reactors in that way. But to top it all off, just for pushing nuclear energy, we are constantly doing safety and redesigning nuclear reactors to provide more energy and safety guidelines, security, all that good stuff. But what we're searching for within nuclear fission is a way to create nuclear fusion, which is essentially like harnessing the power from a star. And we are constantly researching this. And I believe if we do this, they produce so much more energy. They produce 4 times as much energy estimated than a regular nuclear fission reactor, and they produce millions of times more energy than if we were just doing straight coal or fossil fuel energies. So I believe if we look into nuclear fission, we can find our way to nuclear fusion, which would be an almost perfect source of energy that could be considered limitless if we figure out a way to harness it. Thank you.